Right. Let us carry on from what we did last week. Let me just refresh some of the memories. Some of you are not around in any way. I'm not going to start from scratch. But what we looked at was that which was called the Laplace transform. Laplace transform. We said the Laplace represented by L, Laplace of a function f at t is defined as the integral from naught to infinity e to the power minus s of t times f at t what dt. That is how we define the Laplace of a function. But now if you look at this integral here, this integral, we are seeing it for the first time, is called an improper integral. And it is beyond the scope of our course to integrate it. It's a little bit difficult. So we redefine that, and then we say, we take instead the limit as b goes to infinity of the integral from what? From naught to b, then f at t times e to the power minus s of t, what? dt. Right. So in other words, given any function f at t, for us to find its Laplace, we make use of that. We make use of that. This is called, we are finding the Laplace from first principles. First principles. And there are a number of functions that we were able to find their respective Laplace transform. But the study guide that I said you must collect next to my office on the floor there, on page 20, please, you must have, each time I'm teaching you on Laplace, you must have your study guides with you. So now we have table of Laplace transforms. That is on page 20, if you can just go through that. So there are different functions whose Laplace is given or are given. Like for instance, there we've got Laplace of sine at. That is on page 20. If you can just take out your study guides, page 20, Laplace transform. We can find the Laplace transform of a function using principles, using first principles, using that definition. Or a table of Laplace transform is provided to us. Table of Laplace transform provided. Table of Laplace transform is provided. And it's on page what? It's on page 20 in our notes, right? So different functions whose Laplace have been calculated for us are on page 20, 21, up until page 21. So you must have that. So we can always find the Laplace of a function by using first principle, or a table will always be provided. In a test, in an exam, I will give you the very same table for you to be able to go through. So you need not memorize that. But if you were going to sit for the exam, I was going to ask, say, one of the functions to find the Laplace, say, of sine at. But now, because we are no longer writing the test per se. Instead, we have multiple choice. So the Laplace transform table will always be given, and then we'll be asked to do a few examples. Like for instance, if we were to use tables to find the Laplace of the following functions. Let me say, the Laplace of what? Of sine 90. Laplace of sine 90. Now on page 20 in our study guides, Laplace of sine 80, that will be number 3 there. It is given as a over s squared plus what? Plus a squared. So this Laplace here will be a, there is my a. There is my a, which is 9. So it's going to be 9 over what? Over s squared plus what? Plus 9 squared, which is going to be what? To be 81. So this s here is when we use this first principle will end up getting that very same. But now we know it from our table. We can easily work it out. We can easily get it. Next will be the Laplace of what? Of t cubed. The Laplace of t cubed, the Laplace of t cubed, Laplace of t to the power n. That is number 2 in our table there. So the Laplace of t to the power n, it says there it is n factorial. So it's going to be 3 factorial over s to the power 3 plus 1 equals to 3 factorial is 6 over s to the power 4. But we can also make use of the first principles in order to arrive at that. And the Laplace, say the Laplace of e to the power minus 2t, that is also given in our table. The Laplace of e to the power minus 2t is 1 over s plus what? Plus 2. Number 4, the Laplace of what? Of t square shine, sorry. Erase that. Number 4, the Laplace of t sine square root of 3t equals to. We look at that. We have that Laplace on our table again. That will be number 16 on our table. Right. We can find the Laplace of this using first principle, but now it has been calculated for just like the standard derivatives as well as standard integrals. So the Laplace, that is number 16, is t sine at. It says there, so that formula here, we use what? The Laplace of that t sine at in our table, it says is given by what? Is given by 2as over what? Over s squared minus a squared what? All squared. Therefore, the Laplace of t sine square root of 3t will then be equals to. I was just copying that formula there. Therefore, it's going to be what? It's 2. What is a? My a is that. That is my a. So it's square root 3s all over what? All over s. All over s. S comes from that first principle there. Minus a. My a is square root 3, so it's going to be what? It's going to be 3 if I take the square root of the square of this square root of 3 there, then squared there. So that will be the Laplace of that. So the table is handy for us because it quickly gives us the Laplace of different functions. Let us try and evaluate the following using just tables. Oh, I did not say that I'm on this very same page here. Right. Just erase this. Sorry for that. Or perhaps let me use another page, a new one. Right. So use table of Laplace transform to evaluate the following. 1, let's say it's number, whatever the case might be, it's number 4. We evaluate the following, the Laplace of what? Sine 2t times cos 3t. Let us see whether we can find that using our table. Again, we go back to our Laplace transform table and see whether we do have that. Page 20, we don't have this function there. It is not on page 20, neither it is on page 21. So it's not there. So we need to do something until it talks to us.
Sorry, sir.
Yes, sir.
Besacela sir noma usinikeze noma mhlawumbe u4 minutes sithi uyolanda incwadi nathi ukuze sibone kahle.
Quickly.
Okay.
Yes. I will pause for 4 minutes. Please try and pull out your... Yes, yes.
Are we gonna do one for the first principle where we have to do integration by parts twice? I'd like for us to do an example like that because I was attempting it during the day.
Okay, where we use what? Integration by parts twice. What function were you using?
What
function were you using?
I was using the first principle. It had sine.
Or sine.
It had two terms.
Okay, I'll do that for you. Let me just finish up this one. Okay, I'll do that for you.
Thank you so much.
Okay, right. Let's look at this one. If you look at this here, it is not in our table. It is not in our table. So it means we must manipulate this until it fits what we have in our table. Recall something. Recall that there's this formula here, 2 sine x cos y is equals to sine x plus y plus sine of x minus y. In any way, in a test or in an exam, I'll provide you with that. So in other words, look at this, sine x cos y. It seems as if we've got the same thing. Sine 2t cos 3t. There is that. There is that domain structure there. The only thing that we don't have here is a 2. Therefore, we can play around with that. Therefore, the Laplace of sine 2t cos 3t can be written, I need a 2 there, is the Laplace of 2 sine 2t cos 3t. I've multiplied by 2. I must take it out because I want this to be exactly the same as that. Now it is the same. It is given by what? So this is given by, this is my x, this one is my y. So here it says it's sine of what? Of 2t plus 3t. That is that part. Plus what? Plus sine what? Sine 2t minus what? Minus 3t. That gives us half into, sorry, Laplace, I'll put L there, Laplace of sine what? Sine 5t plus sine of minus t. That becomes, before I take the Laplace, I still have half Laplace of, there's nothing wrong with this one there. But now here, sine of minus t, be careful. In which quadrant is this angle? It is in the 4th quadrant. It is here in the 4th quadrant where all students take chemistry. In the 4th quadrant, sine is what? It's negative, so we drop that. So it's minus sine t. Now, now this can be written as half into, what is the Laplace of sine 5t? Sine 5t is given as on page 20 as sine 8t. My a is 5. So it's given by what? By a, my a is 5 over what? Over s squared plus 5 squared, that will be 25. Minus
25.
My a here is what? It's 1 here. It's 1 squared. So it's 1. It's 1 is my a all over s squared plus what? Plus 1 squared, which is 1. If you like, you can simplify inside. That is half into LCD. It is s squared plus what? Plus 25 into what? Into s squared plus 1. Take that here. It's going to be 5 into s squared plus 1 minus into what? Into s squared plus what? Plus 25. If you work it out, it's half into what? Into 5s minus s, that will be what? 4s squared plus 5 minus 25, that is minus 20. If you work it out, simplify, that is s squared, that is s squared plus 25 into what? Into s squared plus 1. Further simplify, 2 is common there, take it out. In fact, 4, take it out. You'll see that you'll be left with what? With 2s minus what? Minus 4 into 20, that will be what? 5, nah? 5. All over what? All over, I'm pulling out 4 here. So we're going to 2 outside. Am I right, good people? Now, that's 25 into what? Into s squared plus what? Plus 1. Is that a 2 in front there or what? I've taken out a 4 here. So sorry, s squared. I've taken out a 4. That one is not there. A 4, the XL 5 la. Then that 4, yes. Then I think that one is correct now. Plus 1 here. So that is your answer. Okay. So that is how we use Laplace table. Now, what about this one? The Laplace of number 5, the Laplace of e to the power t sine 4t minus e to the power minus 3t plus what? Plus cos 4t minus t to the power 4. Mind you, can find the Laplace of that, Laplace of that, Laplace of that, Laplace of that. Laplace is linear, not Laplace Lapaya, Laplace Logia, Laplace Logia, Laplace Logia. Or you just apply Laplace 1, pick Laplace outside. Right. But when you apply it, you don't have to use that now. Okay? Right. So what is ET sine 4t? Check our table there.
It's A over,
A, yes.
over A, open bracket S minus B.
Yes.
Oh,
all squared plus
all
A
squared
squared.
plus
Again,
A squared, yes.
perfect. What is my A? My A is this 4, né? So it's
4.
going to what? It's 4 over S minus what? B. My B is from
1.
there. In other words, it's 1 here. Minus 1 all squared plus what? A squared is what? It's 16. Minus Laplace of e to the power minus 3t. It's there again. It's 1
over
S plus 3 in this case. Be careful, we'll talk about this just now. Next, Laplace of cos 4t. Laplace of cos is S over S squared plus what? Plus 16.
Plus 16.
Laplace of t to the power 4 is 4 factorial all over S to the power 5. And what is 4 factorial? It's 4 times 3 times 2 times what? Times 1. 4 times 3, it's 12. 12 times is 24. 12 times 2 is 24. So this becomes what? 24. Remove that there. But your calculator will always give you that. So you'll get 4 marks there in the case that is 4 marks. So direct use of a table. Let's see whether I can find this Laplace here. Laplace 6 of what? Laplace of sine square root of 2t minus square root of 2t what? Cos square root of 2t. We have this from our table. That is on the next page, page 21, Laplace transform table. That I think it's number 18 there. Look at number 18. That is number 18. I hope we can say that. So it is given by what? It is given by my A is what? My A is square root 2. So it is given by 2, but formula says A cubed. Square root of 2, what cubed, all over what? S squared plus A squared, right, all squared. I hope we are all there. When you simplify that, square root of 3 times square root of 3 times square root of 3, that is 2 square root 2. So 2 square root 2 times 2, it's 4 square root 2 all over S squared. Square root of 2 squared, it's 2. What? All all squared. That is your answer there. Right, the last one. We are just using table, the Laplace of what? Of t sine 2t. We have that. We have that, yes. That will be number 14. That will be number 14. Is t sine 80. It says is 2as. 2, my a is what? It's 2s all over what? S squared plus what? Plus a squared, which would be 4 all squared. And this is your answer. Okay, but don't forget, we can always find these using first principles. Okay, good people. Now let us go back to the question that was asked by one of you there, whereby the problem, I think, you'll correct me, I think, find the Laplace, you said sine t, eh? Sine t from what? First principles. In this case, a question like this, now we need to do what? We need to go through the entire process now, even though it is given in our table, but we want to find it from first principles. In other words, using definition. Now let us go through that. It's quite long. Solution. So we are asked to find the Laplace of sine t. How to find the Laplace of sine t? You use definition. Your definition is what? Is this? From 0 to infinity of the function a minus s of t times what? Times sine t dt. We always multiply by that. Okay? But we can't integrate that, is beyond the scope of our course. This we redefine as the limit as what? As b goes to infinity of what? Of the integral from 0 to b of what? Of a to the power minus s of t times what? Sine t what dt. Now, we are here now. Integrate using parts. By parts, we'll say, let u must be what? A power minus s of t, and dv is what? Is sine t dt. What is du? Du, derivative there, it's minus s a, yes, st. Yes.
I'm getting la because we are deriving using e by parts.
Yes.
Ngaba wrong in if ngithe uqala ngithe let I equal to e power minus st times sine.
It doesn't matter. In other words, to simplify matters, you give that a special name. Doesn't matter.
Okay.
Yes. Then your v here, perhaps I'll do that later. Then your v here is minus what? Minus cos what? Cos t. Therefore, perhaps let me just do that. So my integral I is equals to, I'm focusing on that, but we mustn't forget that there is this limit. Né? Whatever we get, we put the limit, okay? Therefore, my integral, it's uv. It's u. My integral, it's uv is a minus stv. It's minus cos t minus integral v minus cos t du times minus se. Is it s? Yes. Minus se minus that what? dt. So that becomes what? Minus a minus st cos t minus plus. This will be minus s is out, is a constant, integral a minus s of t what? Cos what? Cos t dt. Right? You apply parts twice, you recall from S1. Again, let your u. Again, your u here is a minus s of t. Your dv is what? Is cos t dt. What is your du? Your du is minus sa minus st dt. And your v here is what? Sine t. And Again, then from here, these are my I, don't forget, minus A minus ST cos T minus S law. And here I apply parts. U is A minus ST, V is what? Is sine T minus integral what? Sine T, and what? Du is minus SE minus ST what? dt, close that. Clean up inside the bracket here, minus ST cos T minus SE minus ST sine T. Don't forget here, S is coming out, this one, negative, it's plus, but because of that, it's minus. So I'll get S squared here, integral E minus what? ST sine T dt, which is minus S, which is minus S squared integral I, because this is my I. Remember, that was my I. Transpose all the I's one side. All the I's, I will get what? And take I as a common factor. I is common. Xaleba O1 lan no bani lapha no S squared. Yes.
awufaki laphaya uplus masuqedile la u-integrate wesibili.
Ngizokwenza ekugcineni.
Okay.
There's no need. Yeah. So, but if I transpose this, I will combine it with that and take common factor I. Isale no bani no A minus ST cos T nalo minus SE minus ST sine T. As I will move out, there was a limit in front. Therefore, mind you, the Laplace of sine T is equals to the limit as b goes to infinity of what? Of what I've integrated now. Wait. Even though we're fast. So now if I make I the subject of the formula here, I'll have to divide by that. So this becomes E minus ST cos T minus SE minus ST sine T divided by what? S squared plus 1. Bracket there. That becomes. But this, what I've divided with here, is a constant. There's no T here. I can take it in front. It's 1 over S squared plus 1. Then limit as b goes to infinity of, don't forget here, 0 and what, and 0 and b. Let us do the substitution. Where there is b, I put that. It's A minus SB cos B minus minus S A minus SB sine what? Sine B minus into. If I put not here, that will be 1. That will be 1. If I put not here, that will be 1. And then minus, if I put not here, that will be 0. Sign of not is what? It's not. So I'm left with that. That becomes 1 over S squared plus 1. The limit as b goes to 0. This will be 0. 0. Limit as b goes to 0. Minus 0. Minus 1. There's no b here. Minus 1. Minus 1. It's plus 1. It's supposed to be plus 1. This is minus. So minus into 1 minus that. So that one, I think, should be plus 1. You'll have to check that. So 0, 0, and 1. So your answer is 1 over S squared plus 1. Indeed, the Laplace of sine t, Laplace of sine t is exactly given by that. Okay, we can show it from first principles as we have just done. Remember, the Laplace of sine Laplace of sine et nina, et is a over s squared plus a squared. In this case, my a is 1 here, so it's 1 over s squared plus 1 squared, just 1, and that is that. We can show it. Even though, that is why I said you are not writing a full paper. By a full paper, I mean your paper will always be a multiple choice. Yes, ma'am. Yes.
To say if you ask us to do
Huh?
hello, can you
Yes,
hear me?
yes. Yeah, yes, I can hear you.
So
What is the question?
I'm trying to say that, so it's, if you request us to do it in first principle, you can always verify the answer by checking if it matches on the table.
Yes, 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 yes. And I've just said that you are lucky because our tests now are mostly in multiple choice. If it was a straightforward test, a question similar to this, I would possibly ask. You get what I mean? But because now we are busy with multiple choice, it's not easy for me to ask this question. But if you look at my previous question papers, a question similar to this one is always there where you use first principles.
Siyakuzwa, sir. Siyakuzwa.
Sharp, sharp. Now we can use table. So we can use first principles if we are asked to do so, but our table is there. Let us move on then. Next, properties of Laplace transform. Properties of Laplace transform, very important properties, very important. Property one is called the shifting property. It's called the shifting property. Let us start from what we know. We know that now if you are asked to find the Laplace of any function f at t, our answer will always be f at s. In other words, is a function in terms of s. Laplace of sine at is blah, blah, blah. A over s, there is s. So if we are asked to find the Laplace of any function, we'll know that the answer will be an answer in terms of s. That is what I'm reckoning here. I do understand that. Laplace of f of t, I will get blah, blah, blah function in terms of f. Right, therefore, what will happen if we are asked to find the Laplace of e to the power bt times f at t? What this does, this is an exponential function. What it does on f at t, if we are asked to find the Laplace, it says is f at s minus b. This b here is that b. So this is called the shift. If you look at that, the s, the shift is on s to the right. If you can say that this is negative, equal to 0, and solve for p, s will be p. So s to the right. Okay, so in other words, the role that is played by this is given by that. Let us see whether our table confirms that. If you look at number 8 from our Laplace transform table, do you see t to the power n, e to the power bt? Do you see that there's a shift on s by b amount? Do you see that s minus b? So that is the rule that is played by what? By the exponential function when it is multiplied by some other function. So there is this function. This function is multiplied by e to the power bt. What it does, it shifts s by b amount, by b amount. So if this b was positive here, the shift will be s minus b. If it was negative, it would be s plus b. Examples. The Laplace of what? Of a to the power 2t sine what? Sine 10t. We start from the known to the unknown. So what is it that we know? We start by saying find the Laplace of sine 10t first. We want to see the role that is played by that. Find the Laplace of sine 10t. We know that it is 10 all over s squared plus what? Plus 100. That is Laplace of sine 10t. Therefore, the role played by e to the power 2t Sine 10t is, the shift is on S. So it's 10, there's no S on top.
Hayi mina angisakuboni se.
Awusamboni?
Yes, angakwenza yini la kube tena ungavela enye inkunzi la emva kwaloko i-screen nje sa-blank usuvela la phezulu kancane.
Hayi, akuyona inkinga yakho, abanye bayangibona?
Yes.
Yebo siyakubona thina.
Hayi, inkinga yakho baba. Then
Hayi
i-shift
kumina
S.
siyafana sena kumina kunjalo sena. Yebo leyo.
Uthenga amafoni amadoda.
S mayithengana amafoni nange.
Ayathenga amafoni emadoda.
Hey, laptop.
Walo khuluma leyo nkulumo leyo manje.
Laptop le.
Oh.
Ya laptop yakho isiphakathi.
Hlangana nenkinga zethu.
Intando nange isithusa.
Asingene lapho thina.
Ubuka manje sonke sesiyathinteka bafethu ungasifaka enkingeni zenu.
Right? That is the shift. So look at this S. S has shifted by -2 because that one was positive.
Amafoni lapho.
Number 2, the Laplace of what? Of e to the power -3t cos 4t. We start from the known to the unknown. What is it there that we know? That is, we find the Laplace of cos 4t, which is given by what? The Laplace of cos is s all over s squared plus what? Plus 16. Now, role played by that. Therefore, the Laplace of a minus 3t cos 4t, don't forget, the shift is on s. So it's s, this is negative, so it's plus 3 all over, there is s again, s plus 3 all squared plus what? Plus 16. Please be careful of what we are doing here. We'll come back later when we talk of the inverse Laplace. Yes.
Ubuze shift uyibona ngami ukuthi ngiyabona kahle lapho thisha.
The shift is when the function is multiplied by the exponential. Yeah, nonsense, yes. Laplace of f at t gives us f at s. Né? Then when e multiplies f at t, it shifts the s by the index of the coefficient. Okay. Right. Number 3, we can shift as many functions as we possibly can. 3, the Laplace of what? A to the power -t cos what? 5t. Start from the known. What is it that we know? The Laplace of what? Of cos 5t. And from our table, the Laplace of cos 5t, that is number 6, it is s over s squared minus a squared. Now, therefore, role played by the exponential. Therefore, e to the power -t cos 5t, shift on s. So it's s, index here, it's -1. So it's +1. Coefficient in front of t is what? Is s plus 1 all squared plus what? Plus 25. So please, so in future, if I say, if we reverse the process, we'll talk of the inverse Laplace. What is s plus 1 all squared over, of s plus 1 all squared plus 1. What function is that? It must be easy for you to recognize. It's a cos function, because who cos s over s squared plus what? Plus a. So that function has shifted to the negative side of x by 1 unit. So original be e to the power -t what? Cos what? Cos t. But we'll talk about that. We'll talk about that. And then number 4. Laplace of what? Of a to the power t times t squared. What is it that we know? We know that the Laplace of t squared is what? It's 2 factorial over what? Over s to the power n plus 1. That would be s cubed. Therefore, what is the role played by e to the power t squared will be equal to 2 factorial. It's a 2 over what? Over s. Shift on s. is S, it's plus 1 there, minus 1, what? 1, 2. So what you have seen here is the shifting property. That is property number 1. We look at the next property. Property number 2, very important one. Number 2 is that which is called multiplication by what? By t to the power n. Multiplication by t to the power n. Again, we recall, we know that if we are asked to find the Laplace of f at t, we'll always get what? F at s. Right? Now, therefore, Laplace of what? Of t to the power n, multiplication by t to the power n, of f at t, the role played by this t to the power n. It simply says it's minus 1 to the power n times the nth derivative over ds to the power n of the function f at s. All what it says is that you differentiate the fs function, in other words, the Laplace of the function in terms of s, nth times with minus 1 there, minus 1 to the power n. That is the formula which is on page. That is the formula that is on page standard Laplace transform. Where is it? It is right at the bottom, number 31 on page 21. Number 31 on page 21. So in other words here, it will be the Laplace of f at s. Laplace of f at s. Right. So in other words, all what it says is that you take the nth derivative of the Laplace of f at s, e.g. 1. The Laplace of t times what? Times sine by t. Now, we start from the known to the unknown. First, we work out the Laplace of sine 3t. Laplace of sine 3t is what? It is 3 over s squared plus 9. We know that. Now, this is multiplied by t. What is my n? My n is 1. Okay? Therefore, Laplace of t sine 3t, according to that, it's minus 1
times
power 1, because n is 1 here, times d, the first derivative with respect to s, of the Laplace of f at t, which was what? Which was 3 over s squared plus 9. In other words, you differentiate it once. Then let us carry on, find the derivative. That gives us minus 1 to the power 1, it's minus, so it's minus into. Then differentiate. Use the quotient rule. It's s squared plus 9 all squared. Okay? What is here? Quotient rule is s squared plus 9 times the derivative of 3. That will be 0. Minus, we keep 3. Derivative of s squared plus 9 is what? Is 2s. And your answer here will be minus 3 minus into minus 6. That is 3 times 2, because that will be 0. Minus 6s over s squared plus 9 what? All squared. That gives us that and that. It's what? It's 6s all over s squared plus 9 all squared. That is your answer. Okay. Okay. Similarly, good people, I'll give you this one there to me, Zungala. Okay? You are lucky.
Yebo seliyaduma izulu.
Yes.
Therefore,
T squared cos 4t.
iyaduma ngempela TJ.
Yeah. Yes.
Don't scroll the puzzle. There's something I wanna see. I'm just gonna take a screenshot. Yeah.
Okay. Good people.
Thank you.
Right. Good people. May I just stop here? And
Yes.
your third test is when we come back. Okay.
Oh, sure.
Yeah, it's when we come back.
Min January say.
Right, when we come back. I think by Friday I think by Friday your script for test 2 will be ready. You can come and check in my office. I'll leave them next to my door.
Test one.
Test one.
Test 2,
Yeah,
test
boy,
1.
I think when go say.
Thank you. Test 3, sir.
Test 3
Yeah,
when
what's
we
up,
come back.
man?
Thank you.
Yeah, boy. Ukura hapo mwenyewe.
Leyo nto
Umuhle
enyaziyo
say,
papa yini?
umuhle.
Papa yini?
Inkosi kubusise say.
Kade angusisa ngiyabonga.